Good morning everyone. This is Kameswari from Nalla Nasimhareddy Education Society Group of Institutions, Integrated Campus, NAC and MBA. Today we are going to discuss about Vane Shear test problem. Now, first read out the problem carefully and write given data for any problem. A vane of 80 mm diameter and 160 mm height has been pushed into an in situ soft clay at the bottom of a borehole. The torque required to rotate the vane was 76 Newton meter. Determine the undrained shear strength of the clay. After the test, the vane was rotated several times and the ultimate torque was found to be 50 kilonewton per meter, 50 Newton meter. Estimate sensitivity of the clay. So main in this problem we can calculate sensitivity. Now write given data. What's the given data? Vane of 80 mm diameter. So first diameter D is equal to 80 mm and height is equal to 160 mm. Height H is equal to 160 mm. H is equal to 160 mm. Pushed into in situ soft clay at the bottom of the borehole. The torque required to rotate the vane was 76 Newton meter. So here the vane was 76 Newton meter. Torque T1 is equal to torque required vane T1. The first torque T1 is equal to 76 Newton meter. Next, after rotating, the torque is changed to 50 Newton meter. The several times rotated, the ultimate torque was found to be 50 Newton meter. Now we can calculate the sensitivity. What's the formula required for calculating the sensitivity? So equation for shear strength. First we can calculate the, first determine the undrained shear strength of the clay. So equation for undrained shear strength, S is equal to T by pi into D square into H by 2 plus D square plus 6 D square by 6. This is the formula. Now undisturbed undrained strength S1. First we can calculate here given T1 and T2. Two torque will be given T1 and T2. So in the place of T we can substitute T1. So like this way S1 is equal to, what's the value T1? 76 by pi into D. D is equal to 80 mm. Convert to meters. 0.08 meters. Now we can calculate in the place of D 0.08 square into H is equal to 0.16 meters into 0.16 by 2 plus d square 0.08 whole square by 6. Okay, so now calculate. S1 is equal to 40.5 kilonewton per meter square. Kilonewton per meter square. Okay guys, next followed by you can calculate S2. So same formula, S2 is equal to, what's the value of T2? T2 is equal to 50 T2 by pi into d square into h by 2 plus d square by 6. T2 is equal to 50 into by pi into d is equal to 0.08, h is equal to 0.16. 0.08 whole square into 0.16 by 2 plus d square 0.08 whole square by 6. So now calculate S2. Sensitivity shear strength S2 is equal to 26.64 kilonewton per meter square. Kilonewton per meter square. Here we can multiply it with 1 by 1000. Okay, completed. S1, S2 we can calculate it. So you can calculate finally sensitivity. S is equal to sensitivity of the clay S is equal to S1 by S2. What's the value of S1? 40.5. 40.5 by S2 is equal to 26.64. 26.64. So now calculate sensitivity of the clay. S is equal to 1.52. This is the answer, sensitivity 1.52. So here first the Vane shear test given diameter and height, and torque, two type of torques, T1 and T2. So the general formula for shear strength of the clay undrained strength, S is equal to T by pi into d square into h by 2 plus d square by 6. Here T1 and T2 is there. In the place of T we can substitute T1 and T2. Remaining values are all same. So S1 is equal to 76, S2 is equal to 50. So finally we'll calculate S1, sensitivity S1 and S2. So overall sensitivity of the clay is equal to S is equal to S1 by S2, 40.5 by 26.46, that is equal to 1.52.